Hello, I'm Benjamin Miss, and this is Introduction to Psychology. And for this segment, we're going to be taking some memory experiments in order to get an idea of how memory works. So to start, we're going to do some word lists. I am going to read each list, and what I would like you to do is, at the end of the list, write down what you remember. That's it. So, starting with the first list, mad, fear, hate, rage, temper, fury, ire, wrath, happy, fight, hatred, mean, calm, emotion, enrage. Write down everything you remember from that list. I would say pause the video, and when you're ready, restart it. Here we go. Here's the second list. White, dark, cat, charred, night, funeral, color, grief, blue, death, ink, bottom, coal, brown, gray. Go ahead. Now what we're looking at is memory. How well are you remembering each of these words on this list? Here's list 3. Table, sit, legs, seat, couch, desk, recliner, sofa, wood, cushion, swivel, stool, sitting, rocking, bench. Go. And when you're ready, resume. So pause it for just a moment. And here we are. List 4. Bed, rest, awake, tired, dream, wake, snooze, blanket, doze, slumber, snore, nap, peace, yawn, drowsy. All right, got one more list. So write down everything you remember. Pause it, and when you're ready to resume. And here we go. Here's list 5. Sour, candy, sugar, bitter, good, taste, tooth, nice, honey, soda, chocolate, heart, cake, tart, pie. All right, here we go. Write down everything you remember, pause it, and then I'm going to give you just a one to see how you did on certain words. So I have, let's see, we've got four columns. And what I want to see is how you did on each of these. So we start with the first column. How many of these did you get? Look at all your lists. And did you get mad, white, table, bed, sour? How many of those did you have? Write down the number. For the second list, enrage, gray, bench, drowsy, pie, or I should say the second segment. Next we have wrath, grief, sofa, blanket, nice. And then for the last section, anger, black, chair, sleep, sweet. Now what I want to know, how many of each did you get? And I want you to look at this so that we can get an understanding of how memory works. So usually what we see, I'm just going to give you the generality, we have a really good performance in the first list, or the first column I should say, really good performance on the second column, okay performance column on the third column, and performance on the fourth column between maybe the second and the third, usually. Here's what the columns represent. We start with primacy. Primacy is whatever comes first on the list. Our memory for the first word on the list is really good. You're highly likely to remember the first thing that you see. Our memory for the last word, and this is called recency, is also really good. It's actually can be better than primacy. So there's a couple things that happen with recency. The way we did this experiment, you should do really good on recency because it's the last thing you heard before you started writing down your list. I mean, that makes sense, right? It was, should be sticking right there. So even though primacy is always a strong effect, recency is really strong when you do what's called immediate recall. When you do delayed recall, if we were to wait 30 seconds and then have you write, recency goes away. Words, it basically becomes just like anything else. There's nothing special. You don't remember the last word really well. Then we have mid-list. Stuff in the middle, you remember generally the poorest. So these words were just kind of stuck in the middle. There was nothing really special about them or their position. And then the last one here were words that I didn't say. These words are remembered pretty darn well. And so when you consider the fact that I didn't say these words, but the memory for them is pretty high, this should be surprising. Why are we remembering things that aren't there? And people usually laugh. They're like, no, you said that. And this is great because this is a recording. You can go back and look at the list again, listen to the list, and you're like, he didn't say that. And what's happening? Well, these were created by Roediger and McDermott on an experiment that was done in 1995. And it created this idea of kind of how can we manipulate the memory into remembering things that didn't happen? Well, you do by talking around the word, right? So maybe it's like, I think there's some games where here's the word you want people to say, but you can't say the word. So you say words that are like related, and there's a bunch of related words you can't say either because they're too closely related, and semantically they really set you up to remember the list. So what we have are called semantic networks. It's kind of like if you hear the word fire, certain words come to mind really easily. Truck, red, hot. And so when we had the word, for instance, we were looking for sweet, we had sour, candy, sugar. So all these things that were kind of related, right? And semantically related. Each word on the list was related, and in their original experiments, they found that people remember the non-existent word 40% on the first experiment and 55% on the second experiment. There were some slight differences with more lists, for instance, in the second experiment, but the idea is this. People are remembering the word they never hear. If I were to say, in fact, we use semantic networks to read your mind. If I were to say, I'm going to say a word, I want you to say the first word that comes to mind. I say down. You say, is it that one? I say hot. You say, is it that one? I say cat. You say, was it dog? Now we're going to do another experiment, and I'm going to show this next slide only briefly. 50 milliseconds, maybe a little more, but I want you to write down everything you see on this next slide. This segment is about sensory memory, memory that exists in your senses. Now, you ready? Here we go. What did you remember? Write it all down. You might be saying, Ben, that's not fair. There was too fast. There's nothing there. That's perfectly fine. But when you write down as many of the letters as you can remember, people usually get 3 to 5. So this is from a experiment by George Sperling from 1960, and they was basically using very early technology to present things for a very short period of time, and then trained people to pay attention to only certain parts of it. So now I'm going to show you another list. I want you to only pay attention to the bottom line, the last line we see. Now, can you get all those letters? Was it a lot easier when you were focused only on a small component of it? Sperling's study showed that we remember for milliseconds, for maybe up to 100 milliseconds, quite a bit of the array, but it decays very quickly. It's almost like turn your head and look at something that you're not familiar with and then close your eyes immediately. How much of that can you kind of go through? How much can you access? You find that you really can't access that much. It decays very quickly. So whatever you were focusing on is there. What Sperling did was he showed that everything is there temporarily for a very brief time. People would look at the stimulus, and he trained them to respond based on a tone, like a high, middle, and low tone. So he'd play the tone, and then the people would respond only to the line, top, middle, or bottom, based on the tone. And what it did was he played the tone after they saw the array. And so he would vary the length, the distance from the tone, and it would affect how much the people were able to remember from that, right? So the key here is flash the array. You see all three lines. Play the high tone, and then ask them to, immediately after the array is gone, they remember the whole thing. Middle tone, same thing. Bottom tone, same thing. They remember whatever is there if that tone is basically immediate, which means they can grab anything out of that sensory memory, but it disappears very quickly. All right, you ready for the next experiment? We're going to do 5 lists. You'll see a string of letters for 3 seconds, and then you'll see a dark slide for 1 second. When the slide then turns white again, write down everything you can remember. You ready? Here we go. How'd you do? Write them all down. Here's the next one. How are you doing? You still remembering them? Pretty good. And upcoming next. How'd you do? Are they there? We got 2 more lists. Here we go. How'd you do? Write them all down. All right, last list. Write them down. So how was it? Where'd you start to have trouble? For most people, you start to have trouble around the 3rd list. And the reason for that is it's basically filling up our working memory store. This is also called digit span. So we look at these lists, and the third list had 8 letters in it, which is tough because there's a lot to remember. The second list had 6. That's well within the margin of error for most people. Once you get to 8, it becomes difficult for a lot of people. And once you hit 10, nearly impossible, right, for most people. And then 12 is just people, in the classroom, they will drop their pencils like, angrily, like this is hard. However, there's a couple interesting things about these lists, which are helping us to understand another concept. Chunking. When we remember information, we often grab whole pieces. So if you look at the end of number 4, M-A-U-X, you might pronounce that, you might be able to pronounce that mox or meow or some other way that is you're able to remember that whole piece all at once. So this becomes only really 7 pieces of information. For the last one, you see bum on RV at the end, where you can almost say that as a thing, like kind of grab it all together. When it comes to memory, we are able to chunk things. So Miller came up with this idea that we have this, what he called the magic number, 7 plus or minus 2, which is what we can actually remember. However, he didn't dismiss chunking, and some other researchers like Cohen later looked at, well, we're actually grabbing multiple pieces. If you just look at kind of what people are capable of attending to in their memory, it might be closer to 4, right, being the average amount of pieces of information. So there's some really interesting things here having to do with what we're able to remember. Chunking means you grab a piece, right, like a whole piece of this list, and it only takes up one piece, one part of one of those, components of memory. So studying the actual size of our working memory is difficult. There's strong involvement, and there's two terms here that we may remember from the biology stuff, MTL and PFC. MTL stands for medial temporal lobe. The medial temporal lobe is where we have our hippocampus, and our hippocampus is heavily involved in putting information into memory. We also have PFC, which is the prefrontal cortex, which is what we associate with kind of encoding and storing things into working memory. So we kind of keep them active there. Like if you were to be repeating something to yourself, there'd be a lot of activity. So these experiments on memory should help us to understand some other bigger concepts when we're talking about memory. So I've hoped you've enjoyed our little tests, that the challenge is useful in enhancing our memory. And I look forward to future discussions. Thank you.